Hi class, so this is our flipped classroom. Here's where you're going to find me throughout the entire semester. I hope this works. This is the first try, so we're going to see how it goes. If there's anything that you want to add, please add to the class Google Classroom comments or something like that. Otherwise you can come talk to me. If I'm talking too quiet, too loud, anything like that, please let me know. Otherwise, let's have fun with this. Alright, so welcome back guys. We're going to be starting our first unit of the school year. So that is going to be our rational numbers and square roots unit. So hopefully you have a notes package that looks something like this. And first thing we're going to do is we're going to put our name on it. So my name, Mr. Berube. And the reason for that is we all have the same notes package we're going to be using. We're going to be studying and work on it. And we want to make sure we don't lose it or mix it up, and if you do, I know where to find it. Date, you can do it, that's up to you. Anyway, let's get going. So, our first lesson in Unit 1, and we're going to break everything down into different lessons, so I'll have one video per lesson, and I'll usually have a video in between that covers how to answer some of the exercise problems. That's how we'll do things the same way as well. But like I mentioned, the flipped classroom, I'm here teaching, and you're watching, and then when we come to class, we're going to do the learning and the hands-on kind of homework that you used to do in the past. So hopefully this all works out for you, and if it doesn't, we'll go from there, but I think it's going to be a great semester. So, lesson 1, we're going to be talking about rational numbers, okay? And so rational numbers are any number that can be written as a fraction with an integer numerator and a non-zero integer denominator, okay? So remember, every number is made up of a numerator and a denominator. Numerator on top, denominator on the bottom, okay? D for downstairs. You can think of it like that. That helps you remember, okay? Because we can write fractions as terminating or repeating decimals, I'm going to fill in the blanks as we kind of go along so it helps you follow along. I won't have them pre-written and we know when to add stuff, okay? So because we can write fractions as terminating or repeating decimals by dividing the numerator by the denominator, a number with a terminating decimal or repeating decimal are rational numbers also. Okay, so even things like -3/4, right? If we go -3 divided by 4, we end up with -0.75. Other example would be 1/4, right? If you do 1 divided by 4 in your calculator, you end up with 0.25, okay? You are allowed to use your calculator all semester, and I would highly, highly recommend it, okay? Our last example here, even though it's not a nice, neat round number, right? We can put this as another fraction, -2 1/3 if we want to simplify it. And then this would equal 2.3 repeating when you put it into your calculator, right? If your calculator ends with 2.3333334, that's just your calculator rounding things off, and it was actually always just 3 to the infinity, and that's where we leave it, okay? So, we're going to move on. Hopefully my notes will be similar to yours. If there's ever any pages that change or are different, don't worry about it. We'll just keep going. Sometimes the formatting of this Mimeo program that I use doesn't work well with the Word documents that I created for you. Alright guys, so sometimes Mr. B's can make mistakes. What I'll probably do is stop my videos where they are, and then we'll refresh. So if things are suddenly like magically different, don't panic, I didn't teleport. We just restarted the video. We're kind of going to smush them together, hopefully, and we'll go from there. So, where I was going to take you guys is working with fractions. So what we're going to say is all mixed fractions can be written as improper fractions and vice versa. So you can take from an improper fraction to a mixed fraction, or a mixed fraction to an improper fraction, and you're always able to do that, okay? So how you do that is you take your denominator and multiply it by your whole number. So in this case, we're going to go 3 times 6, which equals 18. And then we add that to our numerator. So 18 plus 5 equals 23. Okay? And then we keep the same denominator, so it's still out of 6, and we take our number here, our improper fraction, and we add it to the numerator. Okay? And so we can do the same here, but in reverse, right? So we're going to take 25 and see how many times 7 goes into it, right? So again, I would usually recommend starting with your calculator. So you could do 25 divided by 7, which will give you some decimal number, but if you take the whole number, right, that would be 3 whole times, and then find out the difference. Other option is go 7 plus 7 equals 14. Okay, well I still have some room, so 14 plus 7 equals 21, right? Okay, well if I go plus 7, it's 28, which is higher than 25, so that doesn't work, okay? But we can get in 3 whole times for sure. So we have 3 whole numbers, 25 is our whole number minus 3, because that's how many wholes we have here, 21, and that equals 4. So then we have 4 left over. Our denominator always stays the same, and we add it back in. Okay, so we're going to practice that one more time. 4 times 5 equals 20. 20 plus 1, because that's our numerator, equals 21. And then we put it all together. So 21 over 4, and this would be our answer. Okay. And last time here, 5 goes into 60. How many times? Oh yeah, you guys can't answer. It goes in 12 times. So we have 12 holes. The remainder is 2 over 5. And we still have the negative, so that doesn't change. You can add it to the whole number or the fraction. Either one will work. Okay. We can also take our integers, and they can be written as fractions with a denominator. Okay. So any whole number, this is really easy. We can turn it into a fraction. Simply we write the number, and you can put it over 1. This is going to become very important throughout the school year, so don't forget this fact. Any number can be turned into a fraction, right? Because 2 wholes over 1 is the same thing as 2. Doesn't change anything, it's still the exact same number, we've just written it different. One thing you'll learn about mathematicians is they try to be very, very lazy, and they don't want to use their hands and write a lot of information, so they always try and write things as simple as possible, but these two things say the same thing. Okay? Right. Numerator of, or denominator of 1. Alright, let's keep moving, guys. Alright, numbers that cannot be written as fractions are called improper, irrational, they are called irrational numbers. For example, the square root of 2 cannot be written as a number that goes on to infinity. There's no definition for that number, and so the only way to write it is as the square root of 2. There's no fraction that you could ever write that would equal the square root of 2. So there are some exceptions to things, and these are called irrational numbers. Alright guys, I'm back. So we're going to keep going with this. And the next thing we're going to cover is writing a rational number between 2 given numbers. So I'm hoping you've done this before, and if you haven't, that's alright. I'm going to explain it, we're going to be alright. Okay, so first example I'm going to do is write 3 rational numbers between each pair of numbers using a number line. Okay, so number line is the key word here, and so the first thing we're going to do, I'm going to use my fancy technology here, if I can remember how to do it. Yeah, drawing a line. Okay, that way it's nice and straight for you guys, and you don't have to worry about it. I'm going to do another one down here for after too. All right. So with the number line, if we're saying between 2 numbers, we always have to put them on either end, right? And sometimes I like to do nice whole numbers instead of some weird numbers. We can always just have the numbers go to infinity, and then just plunk our numbers in wherever we want. So here, this one goes wherever that way, that goes some other way. We'll put 0 kind of a little bit more to this side, I guess, because the negative is a larger, denomination. So down here, we could say this is negative 3.67, and over here we have positive 2.5. I'm not going to take marks off of it if the scale isn't perfect, but I would advise you to try because it will hopefully not mess you up as much as well. Okay, so if we want to put some numbers anywhere in between, irrational numbers, any number that can be put as a fraction. So if I wanted, I could write a mark here and say 1. That is a rational number. If I want to do it as a fraction, over here I could put negative 2 over 2, and 2 over 2 is also known as 1. Okay, so it works on kind of either side. If you want, you could actually write it as a bit of a fraction. So here, why don't we go 2.5, we'll go a half, and so we could just do 1 over 2. So these are 3 numbers that are between this pair of numbers. It can be positive, it can be negative, it can be a whole number, it can be a fraction. It doesn't matter as long as it's a rational number, okay? So we're going to do the same thing down here, okay? So again, these lines go to infinity. There's no end. Numbers are infinite, right? They just get bigger and bigger or smaller and smaller if we're talking about negatives, okay? So over here we have negative 0.44, right? Because it's more negative than negative 0.43, okay? The easiest way I find when we're talking about negative numbers and we don't want to get messy with fractions is we just start adding more decimals, right? If it's negative, no problem, okay? So something right between the two of these is negative 0.435, right? It's halfway between the two. And again, we could just go slightly smaller, so negative 0.434 if we wanted to be closer that way, or negative 0.436 if we're getting bigger. It doesn't need to be fancy, guys, it just needs to be right. So if you just want to add a decimal and make it work like that, unless I give you some instructions not to do that, that's going to be your best bet. That's how I would do it myself, okay? All right, we'll do a couple more examples here. I draw some more number lines. Sometimes the technology is going to do weird things like that. Don't you worry, we'll just pretend it never happened and we're going to keep going. Okay, so here we have negative 1/4 and then negative 1/2, right? If it's in fractions, you're probably better off to stay as a fraction, but you can always convert it if you prefer, unless otherwise instructed. So in this case, we could write, that's a negative half, okay. So in this case here, we could do negative 1/3 would be somewhere in between 0.5 or a half and 0.25, okay? You could do some more examples if you wanted. I'm not gonna get too fancy here, and go from there, okay? Over here, right, we had a half, which is positive, okay? 1/2, 0 is somewhere in between here, and then we also had negative 1/4, okay? So again, anything in between, you could do negative 1/3 again. You could go positive 1/3, right? And we could also go 1/4, 1/4, okay? So any of these are valid options, totally not a problem, and that's how I would go with it. Okay, we're gonna keep moving. Last section before I turn it back over to you guys, and we're gonna do some practice problems, and then we'll go over the solutions next day. All right, so the very last thing that we're going to be doing is ordering rational numbers, okay? So this is where you go from biggest to smallest to biggest, right? Make sure you pay attention to what I ask. On a test, sometimes I'll ask to go from small to big numbers, or more positive to more negative. Whatever it is, pay attention, because sometimes the order will change, and I will take off some marks for that if I need to. All right, so 3 steps in order to order rational numbers. The first is write each number as a decimal, right? So here, all these numbers are decimals. Awesome. If you look in the next example, not all are decimals, and so we'll want to convert those. We're all using the same kind of unit of measurement, whether it's fractions or decimals or whole numbers or however it is, okay? We're going to then order the numbers, okay, and then you'll state your final answer in the same form as the original question. So we went from a fraction to a decimal, we then have to go back from our decimal to a fraction, okay? So for number 1, right, it's all easy, it's already done for us. We don't have to convert anything from decimals or fractions and vice versa. So we just have to go ordering, right? So here, it always starts most negative is the smallest, okay? Because least to greatest. So small to big, negative numbers are small, greatest whole numbers big, okay? So then we would end up with negative 0.8 continued, okay? Negative 0.8. So this is the same thing as 8. So sometimes you need to draw that hexadecimal to help you remember in your head when you're ordering it. But these two numbers are not the same because this 8 continues to infinity and beyond if you're a big Toy Story fan. All right, positive 0.39, 2.54, and we end with 3.1. Okay, that would be your answer stated final. Okay, next. Here we have a mixture of decimals and fractions, okay? And so we need to make sure we're working with the same unit of measurement, okay? I always prefer just to use, rewrite everything to make sure I didn't miss anything. So at 0.67, that's done. Okay, negative 10 over 3, if we do negative 10 divided by 3 in our calculator, we end up with negative 3.3, okay? And then we have positive 3.8. Don't forget your negatives. They're your best friends or your worst friends if you forget about them. Okay, 2 2/5 is the same thing as 2.4. Again, in your calculator, take 2 divided by 5 plus 2. Okay, we have to add that whole number at the end. And then the last 2 are easy because they're already done for us. Negative 4.6 and negative 1.13. Okay, so now we need to look at what is the most negative number and then towards the most positive number. Okay, so here, again, it's going to be negative 4.6 continued. That was, again, converted weird, but it was there in your notes probably, so we'll go with that. Then we have negative 10 thirds, because that would have been negative 3.3, but again, we have to convert back to a fraction for the correct answer. So once that's done, you can cross it off, you know it's taken care of. You can also cross it off here, but make sure you switch back to where you got it. If you want to put in brackets, negative 10 over 3, you can definitely do that. All right, okay, let's continue. So then we have negative 1.13, 0.67, 2 2/5, and we're going to squeeze in 3.8 here. All right, that's all I have for you guys for lesson 1. Okay, most of our flipped classroom videos will be very similar to this. I'll try and add some humor when I can, but hopefully this is going to help us have a lot more fun in class once we get going. But don't forget to watch these videos before you come to class so that you know what we're going to be learning and talking about. Have a great day, guys.